Добрый день, уважаемые участники вебинара. Меня зовут Оля Лукьянова, и я руководитель кураторских служб факультетов дизайна и дизайна интерьера в Высшей школе «Среда, обучения». Сегодня мы продолжаем нашу серию лекций «Встреч вне границ». Это юбилейная 10-я встреча по направлению дизайна интерьеров. Встречи по направлению дизайна интерьера у нас проходят каждую среду. Еще осталась парочка в 19 или 20:00. Следите за расписанием на нашем сайте. А также встреча проходит по направлению психологии по вторникам и по направлению дизайна по четвергам. Напоминаю, что записи лекций будут доступны уже завтра на английском и на русском языке. А сейчас у вас есть возможность задавать вопросы нашему спикеру в чатике. О спикере сегодняшняя тема посвящена лаборатории дизайна будущего, и о ней нам расскажет наш спикер Николь Колтик. Николь в настоящее время работает адъюнкт-профессором, заместителем директора программы МСДС in Design Research в Департаменте архитектуры, дизайна и урбанизма. В 2012 году она основала Design Futures Lab, одну из первых лабораторий по исследованию спекулятивного дизайна в стране, чтобы исследовать конвергенцию машин, материалов и повествований. Работа профессора олицетворяет ее приверженность антидисциплинарности, работе в очень разных масштабах и развертыванию широко расходящихся методологий. Профессор Колтик имеет степень бакалавра искусств университета Карнеги Меллона и степень магистра архитектуры Калифорнийского университета в Лос-Анджелесе. Немножко про регламент нашей встречи. Как обычно, 1,5 часа, час – это будет лекция, во время которой вы уже можете задавать вопросы в чат, и полчаса – это серия вопросов и ответов. Самый классный ваш вопрос я зачитываю Николь, она нам на них отвечает. Также в процессе лекции вы можете задавать в чате вопросы о среде обучения, и я с удовольствием вам на них отвечу. На этом моя вступительная речь подходит к концу, и я передаю слово Николь. Николь, здравствуйте.
Good afternoon, everyone. Evening, perhaps, in your time zone. I'm very happy to be here, and thank you very much for the introduction. So I'd like to talk today about my work as well as the kind of specific approach and methodologies that we use in my lab. And I think this can broadly be understood as an ecological approach. And considering an ecological approach, I think it's very important as designers that we understand both the idea of everything and the fact that there is every space thing. And so no object kind of exists alone. And whereas once maybe we used to design a piece of furniture or a single room, now we need to understand that all of these different things are kind of combining together. And so if we're working in interiors, if we're working in architecture, if we're working in urban design, we need to understand all of these different factors and forces that are coming into those spaces. And so we're no longer just picking out discrete objects, and we're no longer concerned just with how things look, but rather what is this complex assembly of things that are coming together? And that includes the digital, the biological, the cultural, the informational, and the material. And so I think if we're going to be successful designing in these incredibly complex contemporary environments, we really need to look to other disciplines and see the way that they are kind of attacking problems, the way they're approaching problems. How can we start to pull some of these different methods into our own design work to make projects which are much more robust and much more kind of compelling as we meet the contemporary condition. So one of the things that I'm really interested in my work and a kind of hallmark of projects that I undertake is this idea of multi-scalar design. And so I really am interested in looking at super large scale, super small scale, how are different scales kind of operating within a given ecology or space. My lab, as was mentioned, was founded in 2012 The tagline of the lab is machines, materials, and narratives. So in my work, I'm very interested in the confluence of these three kind of distinct pieces. And so in my lab, we do a lot of computational design. We work with robotics, we work with mechanical systems, we do a lot of digital fabrication. We're really interested in kind of pursuing cutting edge kind of computational design. But that is not just design for design's sake. We're really interested as well as taking a lot of those techniques and then turning towards the material. We're very interested in upcoming synthetic materials, biological materials, as well as speculating on future materials. And then the third piece, which is absolutely crucial, I think even if you have really compelling computational design happening or very neat materials, very cool materials, if there's not a narrative that's tying those together, I think the work is very thin. And so we're very interested in pulling from philosophy, contemporary theory, and really looking at how can we develop narratives that are responding to very pressing concerns facing today's society as well as in the future. And so when we put all these three together, I think that's where we gain really robust kind of projects. And I'm just going to take you through a series of those as we move forward. So this first body of work that I'd like to talk about falls under the heading of design for non-humans. So human-centered design has become very popular in the past, say, 10 to 15 years. We design for humans, we design their environments, we design their products, furniture, objects. But in the past few years, we've started to think about what if we start to design for non-humans. And so I started to get interested in what is it to design for, say, an ocean? What would it be to design for a species of birds? What would it be to design for a cave? And what kind of needs would these non-human things have? And how could we start to kind of design augmentations for them? And so as we're looking at an increasingly ecologically fraught world, we have kind of climate change impacts, we have impacts just of increasing civilization. The idea that we as designers would start to think of, say, non-human things, the environment, nature, as a client, I think is very compelling. So I'd like to run through a few of those projects. This project was initiated in 2008, and then it was kind of a multi-year investigation. Basically, the idea was, how can we design for an ocean? And as we've seen in the news, and this keeps getting worse and worse, we're rapidly losing sea ice. And so the oceans are heating up. As they're heating up, the ice is melting. The ice served a very important function in that it reflected back sunlight. So not only when we lose ice are we kind of melting and increasing sea level, but we're also losing this highly reflective surface. And so when I was thinking about if I wanted to design a prosthetic or an augmentation for the ocean, I wanted to help out the ocean, the thought came to me in terms of the idea of a synthetic iceberg. And so this iceberg that I developed is basically comprised of a number of autonomous robots, and they form together. These robots are quite small, and they can kind of swim, and they form together, and they form this really tight reflective surface, and that surface forms a synthetic iceberg. They're also able to break apart, and so when boats are kind of passing through, they're able to kind of come apart and then reform in these different formations. They're also able to be responsive to kind of current changes as well as temperature changes. So this iceberg is highly adaptable, very easy to kind of attach more units onto it. So it's a highly flexible surface. In my work, I'm really interested in looking at, as I mentioned, other disciplines. And so there's a lot of focus on looking towards biology and what kinds of methods and discoveries can we find in biology that we can then kind of apply to our design work. And so here I was really looking for an algorithm that would help in terms of the organization of these robots as they're forming their synthetic iceberg. And so in biology, there's something called a DLA, or a diffusion limited aggregation model. And this is a way that in nature things branch off. And it's a fairly simple algorithm, but it's quite beautiful and elegant. And so we were using this as an underlying kind of computational set of instructions for how these individual robots would kind of come together. And so here's the kind of basic instructions, and then you can see we kind of generate more aesthetic outputs, kind of looking at how is that going to kind of actually be developed. So here you can see the DLA model. We also use this to figure out, how is some of the information kind of feeding to these units. And here's just a diagram of the way there are a set of kind of undersea cables at certain docking stations that these things are also able to kind of form around. Here's a view from the sky. Here's the robots up close. At night, they have a reflective surface, so they can kind of form together or break apart to accommodate large freight vessels. There's just another view of the project. The next project I want to talk about really involved the kind of development of a series of synthetic caves. And so there were these caves in Croatia, in the Istrian region of Croatia. And what we were seeing there is these caves were highly impacted. And so these beautiful formations of limestone made over, millennia, thousands and thousands of years as this kind of limestone and water are interacting to form these incredibly beautiful structures. But over time, these caves have been highly threatened. People are using them as trash dumps. They're just not being respected. And so you have this wonderful resource and it's being highly impacted. And the thought here was, can we try to offer up a design solution that would help these caves? And so the design for the non-human here is the design for the cave. We're also designing for some of the flora and fauna within the cave. So there's a lot of highly specialized animals and plants that we don't find anywhere else. And obviously, as the cave habitat is being impacted, these animals and plants are being impacted. Some of them are going extinct. So the design is also to help them. Some really kind of fantastical, beautiful things living in there. So we were looking at this region and looking at what are some of the existing cave sites, looking at the cave typologies, so trying to understand just architecturally and geologically where, existing sites are, what are their depth, what are some of the conditions that we're encountering there. So doing a pretty broad initial research into the site. One of the things we discovered in this research is that in addition to these natural limestone caves, there's also a large presence of limestone mining, which is leaving these very large limestone quarries. And so this limestone is mined for, stones used in residential projects, people's countertops, shower tiles, etc. But what that leaves you with are these really vast kind of empty limestone kind of voids. And so we had a thought that these spaces are not being used. They're kind of discarded. Once they pull out the limestone, they then kind of leave these empty spaces underground. And so the thought here was to start to use robots in a novel way, have the robots start to navigate these kind of quarry sites and start to remineralize. So we would accelerate the process, the limestone kind of cave process. That process takes, tens of thousands of years. With a robot and a kind of mineral solution, the robot would kind of drive around and kind of be depositing minerals very rapidly we could start to create a synthetic cave in these abandoned quarry sites, and then repopulate it with the plants and animals that were really being impacted in their own caves. So we're using some computational design in a couple different ways here. We're looking at the kind of existing quarry. We're kind of running digital simulations in terms of how these robots might start to kind of interact with the cave. And then how do we start to develop highly articulated cave surfaces, right? So the limestone is just like a kind of box, but the caves themselves and what the plants and animals need is a much more kind of finely grained, articulated set of surfaces and spatial conditions. And so we propose a kind of series of speculative robots that can go within this space, start to deposit minerals and materials following these specific algorithms, and in that way we generate these synthetic caves. And so here's some screenshots of some of the simulations. And this work is called agent-based simulation. So we're working in a program called processing. We're developing series of agents. In our initial work, they're just represented as dots. We give them a series of rules, and then we kind of let them loose in a defined space. And then they start to kind of interact, follow these rules. A rule might be, you know, when you meet another agent, you do this. When you meet another agent or robot in this space at this kind of point in the three-dimensional space, you would deposit, say, this material. And so we kind of simulate their behavior. And I'll just show you a few videos of some of those simulations. So these are kind of the simulated robots, and we have them kind of interacting in this three-dimensional space. And as they're kind of coming to certain points in space or they're interacting with other robots, they're starting to kind of, again, deposit minerals, starting to kind of continue to add solution, and very quickly we're able to kind of replicate this cave. So this work, even the interface we use here is highly programmable. There's nothing that says, say, this simulation, the robots need to be green, or this line is this pale white. That's all kind of aesthetic dimension and overlay. That's another kind of piece of our work. And so there's the cave intervention, but then there's these kind of intermediate artifacts in terms of videos and drawings that are kind of equally compelling, and we're kind of interested in all range of outputs when we're working on the project. Here we can see some other screenshots of these robots. Here we can see a different behavior in terms of as they're kind of working in thicker kind of blocks. You can kind of see that the scale of this is a little bigger. The previous simulation was very thin. Here we're working at a kind of larger scale to start to get these kind of larger rock formations as they're kind of making their way around. And what we end up with, I think, is a pretty beautiful kind of intersection again of looking at kind of machines in terms of robotics, computational design, materials in terms of how do we deploy kind of minerals in a different way, and then the narrative in terms of designing for non-humans and how we might remediate and intervene. And we think of these things as kind of ecological prosthetics, a way that we start to think about ecologies more synthetically, and how we might kind of insert into ecologies in very precise and targeted ways. This next project I want to talk about is called Phenomenal Machines. This was a fairly extensive multi-year project, and we were developing a whole synthetic ecology, and there was a series of custom robots. These robots were basically kind of gardening. We kind of developed the robots. We gave them this hobby where they were gardening crystals. And viewers of this project, one of the intent was to start to think about, you know, non-humans and how non-humans inhabit the world, as well as how non-humans, specifically robots, perceive the world, and the effects they have as they're interacting and what their perception of that interaction is. And so there's a lot of different pieces nested within this project. The final output of it is a short film, but there's also a series of full-scale artifacts, a series of actual built robots, highly customized kind of robotic terrain. So I'll just go through this project. Here's just a few small images kind of showing the breadth of this in terms of we're using all kinds of computational design techniques, digital fabrication techniques. We're doing custom robotics, custom sensors, 3D printing, CNC milling, custom casting and materiality. And so we'll just take a look at all this. So when we had this idea initially of these kind of crystal gardening robots, which then turned into this idea of they need a kind of highly articulated, completely synthetic ecology. So what is it to build a synthetic ecology? So this is an ecology that is meant to mimic a natural environment. It's meant to have a kind of life cycle within it, but everything that is contained within it is artificial or non-living, non-biological. And so we're started to work with just initially the terrain. So what is the kind of background? What is the kind of environment, the nature of this piece? And looking again towards biological inspiration, various kinds of landscape conditions that we found to be aesthetically appealing, and then really testing out how we might go about designing and fabricating this. And so we do a lot of testing, a lot of iteration. We'll design things in software, then we'll take that to our CNC machine, which is a kind of computer-controlled router, which then we start to kind of test. And we might do 100 of these tests, keep trying things, keep running them on the machine, looking at different effects, and starting to think about when we start interacting with other materials. So those were kind of a base material. Here we start to look at this kind of silicone overlay and how that might start to interact with this terrain. This was one of our early tests. We wanted this terrain to have movement like a natural ecology would. So it was important to us that this terrain could kind of breathe almost, as well as kind of have movement. And there's also liquid embedded within this. So this terrain is able to kind of breathe. And this was one of our very early tests, just working with this kind of air system and seeing how could this thing maybe start to kind of breathe and simulate a kind of living organism as a piece of this ecology. So this was a kind of exciting breakthrough moment in the lab when we were testing this. And again, very rough materials, and obviously we refined that behavior, but that kind of talks about some of our process. This here is a 3D print. So once we started to get a little further along in terms of form, we move scale. So we start in the computer, and then we'll 3D print some prototypes, and then, you know, we'll intersect that with the materiality at a small scale. So this is, you know, a tabletop size model of the landscape as we're moving further along. And then we jump up scale to a full scale. And so we then need to jump to bigger equipment, larger robotic fabrication equipment. And that's the kind of way we work through this, going from the computer to small models to kind of full scale models. And we're using a lot of kind of custom techniques in terms of the way we're taking something from a digital machine, applying a lot of hand work to it as well, to get something that's kind of highly unique. So these are the pieces kind of starting to come together. With this project, there's a pretty complicated, as I talked about, air system that's actually kind of inflating different parts of this, as well as a kind of water system. So all of that needed to kind of be accommodated for. We did very kind of custom molds for this work. These are kind of intakes for some of the air system. And we're working on all of these different things at once. So we've got a lot of fabrication happening on the machines. We've got a lot of computational happening just in the computer, and then a lot of handwork happening with the materials. And so the end result was this kind of really beautiful surface. And this was, again, to be the kind of backdrop to the robots, but the terrain itself was a living, breathing entity, although it was synthetic. And so we consider that whole terrain to be a robot. It's just a kind of robot as terrain. And here you can see the kind of overall environment, and then these are the robots kind of operating within. And this is a full-scale object, so it has been exhibited, and users can kind of view the robots in their habitat as they're moving around, as well as the film, which I'll show a bit later, which was kind of disseminated more widely so people could experience the project in a different way, and if they weren't able to kind of see it in person. So the overall narrative of this was we built these custom robots. They are kind of interacting with these crystals in the landscape, and then the landscape itself, again, is a participant. The landscape helps water the crystals so they grow, and then the landscape helps distribute them throughout the environment. And so here's a drawing of some of the inner workings. And so we've got that terrain, which I showed you before. We've got the robots operating within. Then we've got kind of air systems, water systems, enabling the activities. And so a robot will choose a crystal seed, and then the environment kind of waters these seeds. The seeds are then kind of growing. They turn into kind of these very colorful crystals. The air bladders help move the seeds around, and then as they kind of break apart, almost like leaves falling from a tree, they then get kind of re-watered and are able to kind of grow again. And the robots have a critical role in terms of the way they're picking up the crystals, the way they're placing the crystals, the way they're kind of recognizing and processing the crystals. So another very important component of this project was crystals themselves. And so we started with a lot of different tests of how do you make crystals, and how do we control crystals, and what colors. And so as designers, of course, we're very interested in the way things look. And we made a very concerted decision to make the landscape white, and the crystals, we wanted those to be highly colorful. And that helps because the robots have a vision system and they're able to recognize objects, but the color and the contrast between the white and the color help. But also there was a kind of pretty clear aesthetic narrative here in that we wanted it to be evident what are the influences of this environment on the crystals, and the color really helps with that recognition. Here we're working with some different geometries of crystal. We do more scientific research in terms of the way we kind of methodically analyze geometries and the effects that we're getting from these different shapes. We're then kind of introducing them to a mineral solution. They're growing. There's different types of growth, so we were interested in, depending on the solution, we'd get something very spiky. So this is one type of formation. Or with using a slightly different solution, you would get something very puffy or cloud-like. And so we were interested in understanding the differences and kind of tuning that. How could we be really precise about the type of crystal that would be created? Then this fluffiness, and you can kind of see it here, the way that starts to fall off, that then, as I mentioned, can be kind of crystallized. And so there's this kind of movement of the crystal as it deteriorates across the landscape. There's then these liquid pools. So those crystal seeds interact with these pools. and then start to kind of grow within the landscape. And then we have the kind of third piece, the robot, who's kind of interacting with this landscape. And the robot's able to place crystals, move crystals, and kind of collaborate within the environment to kind of affect this whole kind of process. So one of the things we were really interested in is this idea of allomimetic behavior. And this is the idea that humans can mimic animals, and so they can kind of, in this image here, you see a dog kind of tilting its head, a human tilting their head, and so it's this kind of almost interrelationship that you have with another being, a being that's non-human, and the way you kind of mimic behavior. And so when we were thinking about building a custom robot, there was the question of how do you program this robot? And so we were really interested in, we didn't want to just write code to program this robot. One, it's not very intuitive. It's highly complicated, but it also, we thought, was not going to lead to gestures which were fluid. And we also were interested in the relationship between ourselves and the robot. So we had this idea of how could we program the robot's behavior in a more empathetic way. And so we developed a custom device where we could kind of move the robot. So we build a kind of skeleton of the robot, and we were able to move that skeleton ourselves with our hand. And when we were doing those movements, we had the computer kind of tracking our movements. And in that way, that information was directly transferred to the final robots. And so we taught them our behavior just by kind of enacting it. So we were taking on the role of behavior with their arm and their pinchers, and kind of interacting with the crystals. And that's the way we taught the robot their behavior. Here you can kind of see, this was a very kind of basic robot. We were using some different platforms. This is a Roomba, which is, a kind of automatic like vacuum system. This is just a pretty simple 6-axis robotic arm. We had some custom pinchers to grip things that we developed. And here you can see the way that we would kind of use that controller, and the robot would kind of then learn that gesture and kind of mimic what we were doing. We wanted to kind of develop the aesthetics of the robot to be something new. Robots currently, they have a couple, distinct looks to them. There's the really happy, smooth, friendly robot, which I'm sure a lot of you are familiar with. There's the kind of scary defense robots, coming out of places like Boston Dynamics. You've probably seen these as well. There's like a robot dog. They're kind of threatening looking. We had developed this kind of beautiful synthetic ecology. We wanted the robots to kind of have this, kind of beautiful, sensitive aesthetic to them. So we needed to develop the skin of the robot. And again, we were looking towards biology, specific kind of algorithms, but also we were 3D printing the skin. So we needed a way that the skin could move, but be 3D printed as kind of one large sheet. And so here we were just using a very low cost 3D printer, a kind of early generation MakerBot. But this was able to be printed fully articulated. So when we printed this, we didn't need to do anything to it afterwards. It actually is able to bend from the outset. And here are the kind of custom grips that we modeled as well for the robot. Here you can see the skin. This was all printed as one 3D print, but it has joints actually within it. And so it comes off the printer completely flat, but due to the geometry and the way that we printed it, it's able to kind of move. So it's basically a 3D printed textile. There's the kind of skin large. And then here's the robot as it's kind of getting skinned with this. Here you can just see us kind of, again, working in the lab at these different scales. Here's two of the robots interacting, some of the crystals. Here's programming of the robot. And then there was this kind of secondary aspect of the project where people could actually kind of virtually, with a headset, kind of embody the robot. And so they would have a headset, they'd have this kind of arm piece. They could kind of see what the robot sees and kind of interact within the landscape. And again, we were interested in this idea of kind of design for non-humans and how can we start to think about how a robot senses in the world, how a robot feels, what do things look like from a robot's perspective. Again, there was a full-scale kind of art exhibit of this project as well as this short film. Here's some stills of this film. I won't show the whole film, but I'll kind of quickly just show a few snippets of it. You can find this online, just Google Phenomenal Machines. So here we kind of introduce the different elements. We've got the robot, we've got the terrain, here's the pinchers. Starting to kind of show what might this robot be viewing. Then we start to see how is this landscape kind of breathing. Got the robot starting to wake up. We've got this landscape kind of dripping, watering. Got the robot coming to life, so to speak. Got the introduction of these crystals within the landscape. The robot then starts to interact with the crystals, kind of recognizes them, and then starts to kind of interact with them. And then once this interaction starts, we have the growth happening within this landscape. And so things continue to grow, kind of move around, and we start to understand, what is it like in this ecology from the robot's perspective? What is the robot seeing? And ideas of kind of sensation and perception. So there we go with that. There's a series of projects coming out of my lab, and these projects are mainly master's thesis, and these are primarily interior architecture and design students who come into the lab for a year or a year and a half and work together with the lab, and we do this research through design process, and we're really looking to kind of explore the intersection of machines, materials, and narratives, and we're really looking at software, hardware, materials, fabrication methods, interaction methods, and how can we look to science, to technology, to contemporary society, and start to develop kind of novel responses. And these usually take the form of objects, environments, and experiences. And so we have students kind of working with microcontrollers and sensors, and we have, all kinds of things happening in our lab at once. This was a large exhibit we had with the first cohort. So I had 6 interior architecture and design students creating a set of objects and propositions. And so we had a very large gallery exhibit. And this was kind of our proof of concept of the lab and kind of also, what these students could accomplish within a lab environment and its relevance in terms of interior architecture practice. Here's an overview of some of the projects. So this first project was a sleep terrain, and so this was a highly interactive sleep surface. And the idea here was that this could have, say, medical implications if someone, to prevent bed sores or if someone was snoring. And so we were dealing with a lot of kind of custom robotics and material testing. And then working with silicones, a very kind of popular material for us. A lot of sensors kind of embedded within this large sheet. And then kind of, just customizing all of these things. They don't exist. So in our lab, we have an idea, then we think about how might we go about building this, and then we kind of build it. And you can see there's some tie to this. This was a different way that we thought of kind of shifting terrain. In the robot project, which happened a few years later, we had switched to a kind of air bladder system. But I think it shows the way we start research in the lab and continue to kind of innovate and kind of move forward with those ideas. And so this was a popular piece in the gallery. This project was called Threshold, and it was this new idea of a threshold in an interior environment. Instead of you just walking through a door, say, and you're coming home from a busy day at work, how might you extend that process to have more of a kind of decompression or breathing moment? So there's this idea that you enter this thing, that the light changes, that this puff of air washes over you, that there's a break with your electronic communications, and then there's a kind of re-entry moment and you get some information about, say, your household. And with this, we were dealing with some computational design, trying to figure out the way this thing was going to look. And then we constructed it full scale. So this had hundreds of pieces. We cut these out on our large scale kind of robotic kind of cutter, and then kind of assembled all of these pieces together. And this thing is, again, we moved from model, working at a very small scale, to then jumping up to full scale. And this was a really beautiful piece as a piece of interior architecture, but also had this kind of narrative as well as the kind of computation involved in its design. And here is the kind of exit point. This project was a kind of interactive piece of kind of clothing, and it basically interacted with the urban environment. And so you had these custom jackets and scarves that you wore, and as you're navigating the city, there was kind of like a radio beacon, and it would kind of pull you towards different sites. And so as you navigate the city, you kind of walk around somewhat aimlessly, and this would kind of draw you near through sound. And then when you got to these specific locations, it would provide you, say, a particular music track or information about a historical site. Here was a really looking at a different relationship to an environment, to an urban environment, and how we might kind of subtly intervene in that. This project was about communicating through scent. And so there was this piece that was meant to be within the environment that released scent, and then there was a kind of scent controller. And the idea was you could send messages, and scent is a very powerful kind of emotional device, and that our ties to scent are actually more powerful even than to words. And so this was meant for people separated by distance, say a long distance relationship, and you would have this kind of ambient scent device in your room, and then there's this kind of scent controller, and you could send very specific kind of emotional messages to people. And we were kind of hacking together some different systems, and then kind of had this working prototype in the gallery. This project's called Resurface, and this one was really looking at new types of surfaces in an interior environment. And so the idea was, with synthetic biology, could we use that technology to develop a new set of surfaces? So a new type of flooring, a new type of kitchen cutting board, a new type of wall or window system. and we prototyped these. We were using kind of agent-based simulations to kind of mimic bacteria. And so this was a floor surface we proposed, and these bacteria would kind of swarm around your feet and clean up, bacteria, debris. And so we were looking towards biology, looking at how different bacteria swarm, and then we were kind of projecting that onto the surface. And then visitors to the gallery could kind of interact with this piece. It was pretty popular. This was a kitchen surface we proposed, and we were using a specific type of synthetic bacteria, which when it detected, say, salmonella or an allergy substance or, say, hormones in meat, it would turn a different color. And so this was just a cue when you're kind of cooking. This would give you information. And again, we simulated that. And then this was a last piece of this project using this synthetic bacteria, creating this kind of biological cellulose. This material has been used a lot in kind of green clothing. It almost creates this kind of synthetic leather. And so we had this surface that we developed, a very large piece of this biological kind of textile, and then we were projecting onto it. And the idea here was that these bacteria would swarm around, and we were using a Connect system to kind of control the interaction here. And these bacteria would swarm around, and as you are waving your hand, the bacteria are parting and kind of opening and closing. And so this idea was these kind of highly just a high number of these bacteria could start to kind of work together and start to move within an environment. And so people were able to interact with this and just have another idea about this kind of speculative project. Another kind of thing that I run out of the lab is these advanced computational design seminars. And again, we're really looking a lot at biology. In biology, we find this incredible complexity in terms of how things are made, right? There's so much beauty there, but there's always an underlying logic to it. And we take that logic and try to replicate it through software. And then we're able to design these highly complex, beautiful surfaces and objects by using some of the lessons that we've learned through the kind of aesthetics of biology and the underlying rules that generate those aesthetics. And so in my lab, we're kind of looking at that as inspiration and then trying to translate that into actual things that we can kind of make and interact with. So we're doing a lot of experimentation with software and then generating these kind of synthetic things. And then we kind of prototype them. We do a lot of mold making, so we'll use computers to kind of make these surfaces, and then we'll work with things like plaster, silicone, and then these can obviously find their way into the interior. These could turn into furniture, they could turn into wall surfaces. This student was very interesting. She was a fashion designer, and she was really looking at how might we use some of these techniques. So she was, generating these forms, casting them in silicone, and then these pink objects were 3D printed, intersecting the both of those, and then starting to think about how does that become a garment. And so this was her master's thesis, and she had a series of these really beautiful objects using 3D printing primarily, and then some custom design techniques. And you can see some of the influence again of the biological kind of algorithms that we're using in the lab, and the way that that starts to kind of translate into actual design objects. This project was part of a biodesign competition we were doing. And these pieces were eventually exhibited at this biodesign summit at the MoMA in New York. This project, we were really looking at biology in a different way. We were thinking about how does communication happen in biology, and how efficient is that communication. And then we were really looking at contemporary surveillance, right? So we're seeing more and more surveillance in our everyday environments, right? When we're on our devices, but also in urban environments, there's a lot of cameras. We've got kind of corporate and governmental interest really kind of looking to survey everyone. And so we were thinking about how might people start to communicate in a way that's not able to be picked up by this digital surveillance. So you can't see it, and it's also not happening, you know, on the internet, etc. So there's no real trace of it. So we're thinking about the use of biology as a kind of camouflage strategy. And so we were thinking about the urban environment. How could we start to leave messages? And then how could other people start to pick up these messages? And this is all happening through a biological material that is essentially invisible to, say, cameras. And so we developed this speculative device that kind of could read these messages. There's a garment which you kind of disseminate the message. The information kind of grows biologically within this urban environment, then it's collected, and then it's kind of decoded. And so taking this device, we're not interested in, say, science fiction, so everything that we propose needs to be kind of plausible, exists now or exist in the very near future. And so all the pieces that go into this kind of decoding device exist now. They're just exist at a larger scale. So the speculation here is we made it kind of smaller, that it fits in this kind of portable device. There's, you know, in the past few years, we've had this ability now to encode information in DNA. We can encode images, we can encode words. And so this was kind of the original image kind of put into bacteria, then kind of other bacteria was sampled, and they were able to kind of get that message, that visual message out. So we're taking that insight and using it in this project. So there's some pretty complicated biology involved in this in terms of metagenomics, which I won't get into. But again, the biology here is very sound. We had a biologist on the team, and we were just taking this kind of, you know, principles and kind of existing technology in biology and thinking about the way it could be used in a different fashion for communication within an environment. And that's really tied to this idea of narrative, taking a narrative, taking technology, and then kind of really looking at how that then finds its way into a design. So this is a short video that we made for the project. It just kind of starts to suggest, you know, the narrative in terms of surveillance, as well as how this thing kind of interacts with. Here you can see the garment kind of interacting with the urban surface. That information is kind of replicating. Someone else is then able to kind of sample and pick up the message. We're interested sometimes in the use of film as a way to just communicate an idea in kind of a different way. Obviously, drawings are very important, models are important, prototypes, but also film is a way to kind of provide a different sense of kind of atmosphere or emotion of the project. And so we really work with all different types of outputs in terms of a way to kind of communicate our ideas to the public. And here, again, is just some of the underlying biology of that. And then these are some of the devices that we designed, just the kind of speculative prototypes. And there's one last project I'm going to talk about. This was a student who did a thesis in the lab. We were working with kind of biologist as well. He was looking at Dhaka, Bangladesh, and there's a pretty serious set of concerns there. One has to do with climate refugees and rising water levels. And then there's a really large scale kind of textile economy. And so this is fueled by, very low paying wages. And you have a number of people who are living in very kind of destitute conditions, and they don't have adequate housing. They're also being impacted in terms of where they can afford to live is continually flooding. So we were looking at, again, a couple different factors. How could we start to develop a kind of low-cost, sustainable community for these refugees? How could we start to use a novel material paired with material that was already on site? So there's all this textile manufacturing that already happens, and that generates a lot of textile waste. So we were thinking, can we take that textile waste and turn it into a building material? And then we were looking at how can we use computational design, digital fabrication, to start to think of novel geometries for this housing. So we were using a lot of prototyping at multiple scales, and kind of using like CNC work to kind of model and then carve these out, then making molds of them. And then these were then being turned into the kind of prototypes for these bricks. And the bricks were using this kind of mycelium or mushroom-based material that was then paired with these textile waste. Those bricks were then put together to form structures. So here you can see the bricks that we were prototyping. Again, this is a mushroom-based substrate that can grow, and we paired it with some textile waste. And then these get baked, and then they get sealed with a resin, and they're very robust, but very low cost. And so the idea was that these communities would have a kind of communal set of kind of brickwork, that they could be generating these bricks, that they could then be baking them, and then making these structures at a very low cost, but a very robust material. And so we had a lot of material experimentation, kind of biological experimentation going on in the lab, and then a lot of digital modeling happening in terms of how this geometry and this structure was going to come together. Here you can see some of the kind of hands-on lab work in terms of testing different types of mycelium mixtures as well as different substrates. And then here we have them growing in the brick. We were using genetic algorithms, so we were setting up a series of kind of parameters in terms of sunlight and size and location, and then we were letting the computer run its simulations to get a variety of different shapes that these bricks could form. And then we were choosing, some of the top kind of winners to then move forward with. There was this low-cost bamboo framework that we developed that was informed, again, by this genetic algorithm work. And then here you can see some more typical architectural drawings. We have kind of rising waters that we were accounting for, as well as how this thing made a kind of architectural envelope. And here's just a ton of our prototyping in terms of the bricks, in terms of the overall housing structure. And then here's a proposal for the community and the way that these come together. And, here you can see some of the narrative of the project in terms of the way that site is selected. What do we need? We need bamboo, we need this brick lab, the community forms, people kind of move in, the community grows, and all of this was kind of embedded in the design investigation. And these are just some images of the kind of community proposal. So in the future, things we kind of are working on in the lab now, we have a body of work that we're kind of undertaking in terms of ambient communication. And so the way that in our current urban environment, we can look towards biology and the way that communication happens in biology and think about the way that we can prototype more empathetic, atmospheric, kind of poetic augmentations to the environment. And this would be to help those who are less abled and with less mobility kind of navigate the urban environment. So that's a large project we just received a grant for, and we're kind of undertaking work on that. So in summary, you know, in my lab, we're really interested in a kind of research through design agenda, really looking at different disciplines. How are they working at different scales? How can we take, you know, knowledge from different disciplines, put it together in these very interesting narratives, and then apply our skills with computation, with materiality, with interaction, and really work in a lot of different scales. So as, you know, say architects, designers, interior architects, you know, we're not limited to this one scale. How can we really intervene at a variety of scales and collaborate with a lot of different people? So thank you very much, and I'm happy to take any questions.
Николь, огромное спасибо. Это было, в первую очередь, это было очень необычно, а во-вторых, это было очень красиво. То есть вот эти особенно дышащие структуры, я даже наделала себе скринов, сохранила их просто потому, что я хочу побольше про это посмотреть.
Oh, great.
Спасибо вам большое. Итак, Николь, я перехожу к вопросам. И первый вопрос:
Great.
а какую роль вы сами принимаете в своих проектах? Именно как дизайнер или, возможно, как идеолог, или как вдохновитель, как модератор?
Well, I consider myself the director. So I set up the lab and I set up the main philosophical orientation of the project. So I'm finishing up my PhD in computational design. I'm very influenced by non-human philosophy. And so I would say the majority of the narratives and the underlying kind of conceptual thrust of the projects, that's all originating from myself. I also set up all of the computational design. So I've done, you know, extensive research in that area. I teach a lot of seminars in that area, and I really direct all that work. Sometimes we're pulling in contacts I have in, say, biology or, you know, much more advanced kind of robotics, computational design. I'm kind of nurturing those connections and then overseeing all the work to a high level. And then I really work on the fabrication as well. So it's a collaborative process. Every one of these projects I showed was not really just the student off on their own working. All of us in the lab are usually working on these projects together. So I'm right in there, you know, kind of molding things, you know, working in the computer, doing all of that. So I would say I've got a very hands-on role in the lab, setting the kind of overall direction of things, as well as really supervising and interacting with the day-to-day development of these projects.
А вот вопрос про проект с синтетическими пещерами. А специалисты каких профессий вообще задействованы в проекте? Потому что там и есть и роботы, и при этом создавали ландшафты. Расскажите, пожалуйста.
The Synthetic Caves is a speculative project. So, and again, there is a range. So that project is not built. I just want to make that clear. We were using some mining technology, so geoengineers, but then the primary team was just a set of architectural computational designers. So there was 3 of us mainly working on the proposal, but pooling some expertise from this geoengineering and mining, as well as some biological research in terms of specifically how these caves are being formed and the kind of specifics of what do those animals and plants need.
Николь, вот в своих проектах вы очень много обращаетесь именно к биологии. А были ли у вас еще вот с другими науками, так сказать, коллаборации, и там, например, с литературой, астрономией или там авиамоделированием?
Astronomy sounds amazing. I would love to actually work on that scale. Excuse me. I'm trying to think of some of the other people we work with. Some poets actually have influenced some of the writing of some of these projects. We collaborate with a lot of artists. Say the film that we created, the robot film, we had a fairly robust set of filmmakers, photographers, colorists. So when we don't have the core expertise, we go outside of ourselves with that. Biology, I keep returning to biology and biologists, one, because it's so robust in terms of the implications for design, in terms of structures, aesthetics, information. I think that, biology is the foundation of everything. And so I think it's only natural, and I think it's why we see so many designers working in the current day that are finding inspiration there. But we try to take it a little deeper and not just find inspiration in the kind of surface aesthetics, but really what are the underlying relationships kind of driving a lot of that work.
Николя, как вы вообще дошли до создания дизайн-лаборатории? Как вы поняли, что все, вот я теперь работаю не одна, мне нужна дизайн-лаборатория?
I mean, I had a lot of interaction with scientists and had an appreciation for the way that lab structure operated. And so to me, a design laboratory where you could kind of amplify your effects and kind of, pull together a lot of different resources made a lot of sense to me. And so I was very influenced by looking at some very successful scientific labs, excuse me, and taking that model and applying it to design. And there was a couple interesting design labs in Europe, and I had kind of interacted with some of those colleagues as well, and really felt it was a kind of powerful model that I wanted to put in place. It was a little bit of there was difficulty in convincing my superiors that this made sense. Again, coming out of an interior architecture program, there was some pushback in terms of what are you doing? How does this relate? But I think now, 10 years later, people see the results and really understand how powerful this is and what an interesting skill set it is to kind of offer to designers. So I think the lab model is very powerful, and hopefully we'll continue to see these labs grow.
Следующий вопрос. Кто заказчики ваших проектов? Это пока теории или существуют уже пилотные проекты?
Well, a lot of our work is theoretical or speculative, or some of our customers, as we've talked about, are non-humans, right? They don't pay. So when you're designing for the ocean is a client, but they're not paying. But the most recent grant that we received, our clients are humans navigating urban environments, humans with limited navigation and physical mobility. And so persons with disabilities related to mobility are our client for this next project, but we're taking a highly speculative skill set and applying that to a very real world problem. And so we have the potential to work on more real world issues. And I think this next project will be a great example of that. But we're going to solve that issue. We're going to approach that issue in a much more kind of poetic way, and really bring to bear these different skill sets to a kind of very real world problem. So I'm excited to kind of expand that work. I know people want to see real results, and I think we're capable of that. But we think the speculative work has a ton of value as well to push people forward in terms of the way they think about things, as well as the way they think about designers and our skill set.
Так, следующий вопрос. Какие революционные эксперименты, которые не вошли в лекцию, существуют, но... Так, не так. Какие еще революционные эксперименты вас восхищают? Вот так.
Well, I have a very interesting colleague. Her name is Geneviève Dion, and she's at Drexel. She considers herself a design scientist, but she's trained as a fashion designer, and her work is all about advanced textiles, and really these 3D knitting machines, and then 3D the integration of like sensors and technology. And a lot of her work has very interesting real world potentials. She's developed, say, this garment you wear when you're pregnant that monitors the baby's heart rate and different factors, but also very beautiful garments. And I think, her lab has much more orientation towards real world issues, but she's also dealing with this in a very kind of poetic and sensitive way. I'm also really influenced by kind of collective behavior labs. That's a subset of biology and ecology, really looking at things like flocks of birds, swarms of fishes, bacteria. And I think, they're working at all these scales. They're looking, say, at zebras in Africa with drones and looking at how they're relating versus having these really technical ways that they're putting little cameras on ants and kind of looking at the way ants, say, build bridges. The way they work across scales to me is highly inspiring, and that's some recent lab work that I'm super excited about, because it takes the theoretical and then is looking at actual objects in the world in different ways. Very creative work.
Николь, а с чего вообще начался ваш путь в дизайне? Вы же не сразу начали заниматься вот этими, я скажу, вот для меня странными штуками, связанные с дышащей кожей и так далее, с 3D-принтерами.
Well, my bachelor's, my undergraduate degree is in fine arts. So I started as an artist, and I worked in electronic media, I worked in sculpture, I worked in installation. So I have a really deep skill set in terms of just making objects. And then I pursued my master's in architecture, and I went to UCLA, which, in the early 2000s was really a leader in computational design and digital fabrication. And so I really developed those skill sets. So I've been working with 3D printing for 20 years. So I was really at the forefront of a lot of those technologies. And that had a big impact in terms of my skill set. And then I started to really do a lot of writing and started to kind of get into a lot of contemporary philosophy. And that's when this kind of coalesced, this idea of machines, materials, and then these kind of pressing narratives. And then there was the kind of rise of this new field called speculative design or critical design. And once I was kind of exposed to that, I really kind of joined that community and it all kind of clicked. So I'm a speculative designer who uses my skill set in art, design, philosophy, computation. And that's kind of the unique pairing of myself, and I've kind of just pushed that forward.
Ага, спасибо, Николь. А скажите, а есть ли вот, так как вы занимаетесь спекулятивным дизайном, есть ли понимание, когда его можно будет, ну, когда это перейдет в прикладной дизайн? То есть когда мы сможем, наконец, вот что-то такое использовать? Есть ли у вас понимание этого?
I mean, one of the interesting things, I'm interested in the plausible, so not science fiction. So all the things that we use in our lab or speculate on, they exist in some form. They just don't exist together or in that specific application. So I think the real barrier is a lack of imagination, at higher levels, perhaps in government and corporations. But when we look at companies such as Google, Facebook, they, as well as a lot of the large consulting firms, they are starting to develop foresight or speculative design divisions. And so the role of the speculative designer has become a kind of real profession. This is a new profession, right? It's only within the past couple of years, but bigger companies are starting to understand the value of this. Once there's more of those designers in these positions, I think they'll have a lot more influence to kind of push forward the testing of these ideas. So the things exist now, they just don't exist in combinations as we've suggested them. And it's really, again, a lack of kind of daring for people to really kind of push these forward. But I see potential on the way in these new fields and the influence we'll be able to have.
Мгм. Спасибо, Николь. А скажите, а при разработке робота возникали ли у вас споры с инженерами-программистами? Были ли переговоры вот именно на тему баланса вот этой эстетики и логики?
I mean, this is a great, great question. Our main engineer that we've worked with is unlike any engineer I've ever met. He, prior to working with me, actually read, a significant body of my work. So a lot of my papers. He was very interested in the philosophy and what we were doing. So most engineers, I think, they want to just solve the problem. This engineer was really valued us and valued our skill set in terms of aesthetics, of poetics, of narrative. And I think finding a collaborator like that was essential. And so we didn't have arguments in that way. Sometimes we drove him a little crazy because we were, some of our goals were difficult. And so, but it wasn't a quarrel, I think, because he had that respect for us. That relationship's hard to find. And, there's some things I would like to do with more advanced engineering that I've had trouble finding a collaborator that, thinks it's a valid use of time, I guess. And so that continues to be maybe a stumbling block with some of the projects because the engineer still sees the designer as perhaps the end at the end point of us, like just making whatever they've designed look good. And we're really trying to put forth the idea that the designer is at the beginning, and the designer and the engineer really should kind of have a dialogue and interaction very early on, and that they should have a deep respect for the skill sets of both. Right now, the designer really respects the engineer skill set. Engineer skill set, does not so much respect the designer. And so that issue of respect with design, something I'm really trying to continually push forward. I think as a field, we still have that, issue of respect. And I'm interested in kind of changing that and moving forward.
Николь, что самое важное при разработке именно робота вот из ваших проектов? Возможно, это точное выполнение функций или материалы, или просто вот дизайн, чтобы он был эстетичным?
This is a great question. In the robot project, Phenomenal Machines, where you saw the breathing kind of landscape and that, I think the aesthetics were really at the forefront of that project, but the aesthetics to us were so tied to the narrative, because if the aesthetics were not read in a certain way, I don't think the narrative in terms of us wanting people to understand and try to embody what the robot sees and perhaps feels would have worked. So aesthetics to me was really running at the top of that. But I think one of the key pieces on my lab, when I say machines, materials, narratives, they're never separate. So the three pieces of that, they always are kind of entwined together. And so yes, something might rise a little bit above the other two, but if a project doesn't have all three of them really seriously kind of engaging them and moving the discussion forward, I don't consider it a success.
Николя, как вы подходите к выбору материалов?
Well, materials usually have to do with aesthetics and performance. So say the mushroom. The mycelium material was a little bit less about aesthetics, because it's somewhat beautiful, but it's a little ugly. It depends on your orientation, but it's not, it's not the most beautiful thing. But the idea there was, can we have something that's low cost? Can it be, easily reproduced, and can we use this textile with it, the textile waste? So in that project, the material was more about performance. With the silicone, which you see we use a lot, that material, it fulfills a lot of criteria. It's flexible, it's easy to cast. We think that material is quite beautiful. I showed an example where it was used in a dress versus a landscape versus a bed. So that's kind of a go-to material just because we like the aesthetics of it. Crystals, again, the aesthetics are kind of rising above. So there's a negotiation there in terms of materials, but one of the things we want to be doing is using the materials in novel ways, in ways that they aren't usually being used.
Скажите, а сначала появляется потребность в дизайне, то есть вот нужно что-то сделать, или вам сначала приходит образ, который вы хотите создать?
I would say the narrative, the kind of philosophical idea. That is the underlying kind of conviction, I guess, and that's the driving force. The aesthetics are kind of a way to convey that narrative and a way to apply a lot of our other interests and techniques. For me, the aesthetic is a way to get people to think a bit differently. So when you see something that looks different than you're used to, that to me already sparks some thought in terms of, okay, something different is going on here. That can then help kind of point people or lead them down a different road and be perhaps more open to understanding that there is a narrative kind of embedded within that. But narrative and kind of philosophy and kind of the conceptual kind of point I want to make is the starting point.
Николь, спасибо. Итак, у нас наше время уже подходит к концу. Последние 2 вопроса, и будем заканчивать. И вопрос такой, мой самый любимый. Николь, какая у вас самая большая профессиональная мечта?
This is a great question. I would love to see more of these things exist in the world. I obviously I'm a professor now, but I think my biggest dream would be to have a lab within one of these very large corporations and to have more resources to actually test some of these robotic ideas on a much larger scale. So my ambitions have to do with my ability to work at a larger scale with more money and really put more of these ideas out into the world. So that's my greatest desire. But in the interim, I think being a professor, running a lab, and really introducing the next generation of students to this way of thought and having them kind of take these ideas out into the world is very valuable.
Супер, Николь, прям чувствуется, как вы любите свою работу, вы прям так стали излучать радость и тепло. Ой, и последний вопрос. Посоветуйте, пожалуйста, какие-нибудь, возможно, журналы, книги или людей, на которых можно подписаться там в Инстаграме или еще где-то, которые могут вдохновить наших слушателей, при том, что это не обязательно может быть связано с дизайном. Главное, чтобы вам это нравилось, и вы могли вот через это передать свое настроение, свое вдохновение нашим слушателям.
This is a great question. There's so many. I think if you're not that familiar with speculative design, I would take a look at just the speculative design tag. I love Dezeen, Dezeen. You're probably familiar with it, but they really showcase a lot of interesting speculative
Николя,
design.
можно попросить вас писать в чатик, чтобы я успевала сразу перекидывать нашим слушателям? Спасибо.
So Dezeen is a great reference, I think, just for general design, but they really focus a lot on speculative design. Another place where I see a lot of amazing work coming out of is the Royal College of Art in London. And just some fantastic professors and students kind of working there. Eindhoven University, I will type in as well. Very interesting work. For tags, I think I'm just typing a few. Speculative design, digital fabrication, computational design. These are all things that I find really influential. So there's a few things, but I think looking at these universities, that's where some of the most cutting edge work to me is coming out of, because that's the next generation and really some exciting stuff happening. So hopefully those are a few waypoints. But I really want to thank everyone. This has been a tremendous experience for me. I've never spoken to a Russian audience, but incredibly generous. And I feel a great enthusiasm, and the questions have been fantastic. So I really want to thank everyone for their time and for the opportunity. It's been great.
Николя, вам огромное спасибо. Всегда очень приятно слушать людей, которые по-настоящему влюблены в свое дело и при этом умеют про него красиво рассказать. Спасибо вам огромное.
Great. Thank you so much. Take care.
Хорошо. Итак, друзья, будем спасибо. Спасибо всем участникам лекции. Будем рады видеть вас на других вебинарах школы «Среда обучения» и на встречах вне границ. А еще напоминаем, что прямо сейчас у нас идут наборы на осенние программы. Подробности можете узнать у нас на нашем сайте. До скорых встреч, и будем рады видеть вас на других встречах вне границ и среди студентов среды обучения. Всем пока!